The best way to learn something is to develop a mental model for it. In today's lesson, I will give you a mental model for conditional types, which will give you an intuitive understanding of when and why you should use them. Let's go. You should think of conditional types as your opportunity to create little type functions within the TypeScript type system. Now, when you think of functions in any programming language, there will be some inputs and outputs. Just like functions can take parameters, types in TypeScript can also take parameters in the form of generic arguments. And the return of such a function are the types represented by the leaf nodes within the conditional type. Now these types are called conditional types after the conditional operator that exists within JavaScript. The question mark colon operator within JavaScript is called the conditional operator, and these types are called conditional types. The inputs of a conditional type are a type, and the outputs of a conditional type are also a type. For example, here we input the type number into the isNumber conditional type, and then based on the logic that we've authored within it right now, it outputs the literal type number. And similarly, if we were to input any other type other than a number, for example, we input a string into the type position, based on its current logic, it would output the literal type other. You could think of this conditional type as a JavaScript function that takes an argument, does some test on the argument, and if that condition is true, returns one value, otherwise returns another value. And while this particular piece will only execute at runtime, the conditional type logic is executed by the TypeScript compiler within the type system. Now let's look at a real-world use case of this feature. Instead of limiting ourselves just to the number type, we can go ahead and create a type which takes into account any of the values provided by the type of operator within JavaScript. And then we can create a generic function that takes an argument of type t and then returns the type name for that particular t using the type name conditional type we just created. Within the function body, we'll just return the result of the type of JavaScript operator. And now we can go ahead and invoke this function with any of the primitive types that are provided by JavaScript, and what will happen is that these inputs will get passed in as type t, and the result will get passed out as the type name of type t. And because of that conditional type annotation, TypeScript can infer the output based on the input immediately at compile time. So if you pass in a string, you get a string, you pass in a boolean, you get a boolean, you pass in a function, you get a function. And pass in anything else, you get an object. Now a fun fact about JavaScript is that when you pass null to the type of operator, it actually returns a string object. And therefore our current implementation of the type name function, where it returns the literal type object for the input argument null, is correct. But thanks to the power of TypeScript conditional types, we can actually do better than the native type of t operator. We can add another condition which checks for null within the TypeScript type system and returns the literal type null. And then within our runtime type name function, we can add any other conditions and return the values if those conditions are met. And now our type name function uses TypeScript's conditional type system to return a better result for the null value. We could easily keep on adding other conditions within our conditional type as well as runtime type checks within the type name function to make a function that is specific to our projects and meets our needs more than the built-in type of t operator. As always, thanks for watching. Smash that like and subscribe, and I'll see you next week with another video lesson. Till next time, take care.